Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says stock span problem. The problem goes like the stock spans problem is a financial problem where we have etc etc. Now you are given an array ARR representing a daily stock prices. The stock span of ith day is the number of consecutive days up to day I, including day I itself. This is interesting, and for which the prices of stock is less than or equal to price on day I. Return the stock span for each day in the given sequence. I know it can be a bit difficult to understand because of the wordings. I hope they can make good wordings out of it. But the overall gist of the problem goes like, and it's very similar to one which I solved earlier from lead code. And it's not a financial problem once you understand this. Again, it can be, but the overall thing which they're asking is, hey, I'm at day 0, 1, okay, 1, 2, 3, which are actually index, and days as well, whatever you want, and these are the prices. I wanted to understand that if I'm standing at any day, how many days are previous to me are lesser than or equal to in the number. So suppose I'm standing at day 2, how many numbers are lesser than or equal to me on the left hand side. So there's 100 which is not equal, 80 which is lesser than, and 90 which is equal. So there are 2. Likewise you have 20 which will be 4, 80 which will be 1, and 100 which would be 1, because you're considering the current day as well. So 1124 it is. So what you wanted to find is previous elements lesser than or equal to current price. Make sense? So let's take this one, how we are going to solve this. So one thing is that, hey, you can iterate from each element. Like if you are on this index, go from start to this index and understand that how many elements are there. That would cost you of n square, because you are running 2 loops, one for understanding how many things are on my left, and one for setting each of the n elements. So n square. So that would be not an optimal solution. So it's a brute force approach. Can we optimize this? Of course we can optimize this. The only thing you wanted to know is what was the last number which violated, or how many numbers which were good for me, which are good, or last bad number, I would say. So for 90, the last bad number was 100. So I wanted to understand only 100, what was the bad number. So I will skip 80 or whatever things were in between. So if it was 80 or there comes 70 what not. So I would just eliminate all those possibility and go to 100. So in that case, let's say 100 we had, then have 80, then I have 70, 40, 20, 10, and then I have 90. In our brute force approach, I would go ahead to this, and this. But now, if I can have any lookup or any data structure which would give me directly 100, then that would be fine. So 90 would, instead of going on iterating all those things, it would just go ahead from this point, it would go till here to 100. You got the gist. And again, if something else comes up, in our case it was 120, then 120 is violated by whom? Is it violated by 90 or is it violated by 100? Obviously it's not violated by anyone. So let's take 95. So 90 is not obviously in the picture, 900 would be in picture, but within your brute force approach, you would just go ahead and traverse all those things. So another understanding which I have is for next element, if previous was violated, then the passing element, then the passing elements would be same for current as well. Was not violated, I mean. So 90 didn't violate it to 95. So can I use 90's lookup? Yes, I can use that. So for 95 as well, I can just skip all those things and I can go to 100. How can I do that? Again, the elements are coming one by one, and I need to keep track of this, then this, and so on. And once I got a violation, I'll remove this one, the last one. So if I'm removing the last one, last input and first two out, it's nothing but stack. So I would be using stack to maintain the lookups till what possible way where I can span myself. I'm sorry. So I have an array list to return, so that's my return new array list. Also I have a stack which would be integer. It would mostly contains index only. So this is a stack of indices, new stack. Now how I'm going to proceed. So while I'll have an iterator int itr, which is equal to initially 0 because I'm starting from 0 index. Itr is less than price dot length. Now I want it to go ahead and I want it to fail. Ultimately I'll return the result, not an issue with that. So I wanted to understand that, hey, is it violating? Next, if yes, remove, because I don't want violating things, I want just good things. If yes, remove, and in this case remove means pop. And once I'm sure that, hey, my last element is the valid index, then I would count, store the count, and maintain the stack, maintain index and stack, index of iterator, like, or I would say update, advance the iterator and stack. So cool. Hey, is it violating? How would I know? I'll check if it's violating or not. How would I get to know that, hey, my stack dot peak, it will give me the last element index, and I would get the price of this one last element, and I would say that, hey, if the last element is smaller than or equal to, for that matter, which is this condition, lesser than or equal to, it's a good one. And I don't care about these good ones, because these good ones were just keep on, these are the good ones, right? I don't care about these good ones, and I wanted to just remove them because I'm just caring about what violated me. So just, and lesser than or equal to whom? Oh, okay, me, obviously. So price of myself, itr. If that is happening, then remove it, stack.pop. So I'm popping it out. So remove unnecessary good items. Again, I'm taking out a stack directly, so I wanted to check, but stack initially is empty or not. So if it is empty, I don't want to do this. So if it is not an empty, then only do this. And I wanted to do this one time or multiple times. So why? Once this is done, I'm sure that I'm at a valid index. So I would check that, hey, if stack dot is empty, if it's empty, then I am sure that there is no such item. So if it is no such item, then there is all good things. And if it's all good things, such as in the case of what do you say, where is the item? Oh, such as in the case of 120, there are all good things behind us, then I just do my index plus me. So my index, what is my index? Is ITR plus me. Me is, I'm only the one item, and that I wanted to add into my result. Else, here is an interesting part. If my stack is not empty, and if my stack is not empty, there is someone violating. And who is that violating man? In our case, over here, for 90, the violating man was 100. So from my iterator, my index to 20, between them I got my answer. So that is res.add itr minus stack.peak, because stack.peak would give me the index of that person who violated, and itr is my current one, so that would be the count. Ultimately, I'll advance the iterator and I would put currents on stack.peak itr. Let's compile this, if this solution works for sample test cases or not. Okay, there are a few compilers. I see 54. Oh, it's not peak, it's push, my bad. Okay. It successfully passes the first test case. Let's check for rest all the test cases as well. And this was a classic problem of stack, by the way, where we have a monotonic stack. Such kind of stacks are known as monotonic stack. Why so? Because once you understand that what is a stack, okay, stack scenario. Why? Because the stack is in the fashion. Once you trace down, do a dry run of this, you would understand my stack is having only descending order of elements, and that's the reason it's in a monotonic fashion. So that was a monotonic stack, and it has been a favorite question of these many companies. We also accepted, adhered, respected these time complexity and space complexities. So for more such stack, queues, videos, click the video on your right, and I'll see you in the next one.